Hello, and welcome to another Algebra 2 lesson. This is lesson 9.7. Our objectives: use trigonometric identities to evaluate trigonometric functions and simplify trigonometric expressions. Also, verify trigonometric identities. Fundamental trigonometric identities. We have the reciprocal identities. Cosecant and sine are reciprocals of each other. Secant and cosine. Cotangent and tangent. Then, tangent can be defined as sine divided by cosine, which would make cotangent the reciprocal of that, or cosine divided by sine. Here are some new ones. Pythagorean identities. These come from the Pythagorean theorem of a squared plus b squared equals c squared. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. So later on in these notes, near the end, with the extra examples, I will show you how to get this from a squared plus b squared equals c squared. But you can also see that these Pythagorean identities come from this fact, that x squared plus y squared equals the radius squared on the unit circle. R is 1, so 1 squared is 1. The x squared is cosine squared on the unit circle, and y squared is sine squared. Here's something really important you need to understand. When they put the squared next to the s here and next to the n here, that means that you are finding the cosine of the angle and then squaring it, or the sine of the angle and then squaring it. So to keep us from having to write parentheses, we move it in. So sine squared theta means sine of theta, then squared. Cosine squared theta means cosine of theta, and then squared. If we wrote it as, say, sine theta squared, if you ever see this, that means you're squaring the theta and then finding the sine. So we don't want to do that, because that's usually not what we need. So you're going to see it this way. Cofunction identities. If you take a sine graph and you shift it pi over 2, it looks just like a cosine graph. And the sine of pi over 2 minus theta is equal to the cosine of theta. Cosine of pi over 2 minus theta is equal to sine theta. Tangent of pi over 2 minus theta is cotangent theta. Then negative angle identities. Sine of negative theta equals the opposite of sine theta. For example, the sine of negative 45 would be the same as the opposite of the sine of positive 45. Cosine of a negative theta is equal to cosine theta, and tangent of negative theta is the opposite of tangent theta. Evaluating trig functions. It's important that we start noticing in quadrant 1 from 0 to 90 degrees or 0 to pi over 2 that all of the functions have a positive sign. Sine, cosine, and tangent and their reciprocals are all positive answers. When we move over to quadrant 2, that is backwards, which is the x, and then the y is still up, so that's a negative and a positive as far as the x and y goes, which means your cosine is going to be negative, your tangent is going to be negative, so only the sine and its reciprocal are positive. In quadrant 3, sines and cosines and the reciprocals are negative. Tangent is positive because the x and the y are negative, and tangent is y divided by x, so that would make it a negative divided by negative. It gives you a positive. And in quadrant 4, sine and tangent are negative, but cosine is positive. So if we focus on just the sine, cosine, and tangent, knowing that the other three are their reciprocals and will have the same sign, which functions are positive? All of them. Just the sine value, just the tangent, and just the cosine. So if you remember the ASTC, all students take calculus. All students take calculus, starting with quadrant 1, then 2, then 3, then 4. All of sine, cosine, and tangent are positive in this quadrant. only sine is positive in this quadrant. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. And then also the reciprocal functions will match their sign. All right, this is going to help us because the way we're going to solve these problems today. Example 1, find trigonometric values. Given that sine of theta is 4/5 and theta is between pi over 2 and pi, find the values of the other 5 functions. So sine of theta is 4/5. They want us to use that Pythagorean identity of sine squared theta plus cosine squared theta equals 1. Sine theta is 4/5. Solve for cosine. Okay, need a common denominator. 1 is the same as 25 over 25. And then 25 minus 16 is 9. So we get 9/25. Now, that's cosine squared. Find the square root of both sides. So that cosine squared, cosine, no longer squared because we did the square root, equals plus and minus. Square root of 9 is 3. Square root of 25 is 5. Now, given this information, we have to decide, is it supposed to be positive or negative? For cosine of theta between pi over 2 and pi, that is over here. And it says only sine is positive. The other functions, cosine and tangent, are going to be negative. So we get cosine of theta is -3/5. We already had sine was positive 4/5, so now we can find tangent. Tangent theta is sine over cosine. So sine was 4/5. Cosine is -3/5. They both have 5s on the bottom, so when you multiply by 5 over 5, those 5s cancel out. Tangent of theta equals -4/3. All right, sine is 4/5. Cosine is -3/5. Tangent is -4/3. Then we can find all the reciprocals by just flipping them over. Okay, what's the reciprocal of sine? What function is the reciprocal of sine? The one with the s in the middle. Cosecant. So cosecant is the reciprocal of 4/5. Reciprocal of cosine is secant, -3/5. And the reciprocal of tangent, cotangent, and there's our other 3 functions. Great, and that was example 1. Example 2, simplify. All right, now we want to use those functions they gave us. those equations, those formulas. Tangent of pi over 2 minus theta. What did this one equal? Well, pretty sure it's cotangent, but let's go back and find out. Here it is. Now, you have these on your pink sheet, on the reference sheet I gave you in class, or the one that I put on Canvas for you to download. You can find it. It's on the second page, the same one that had the unit circle. You go to the second page. This is known as a co-function identity. It's in the middle of the second page. Tangent of pi over 2 minus theta is cotangent theta. So we get to substitute and replace that with cotangent theta. So this, we're going to remove that, replace it with cotangent theta times sine theta. And then we want to simplify some more. So when we're simplifying, we're going to make some substitutions, and often we will rewrite things as sines and cosines. Tangent is sine over cosine, but cotangent is cosine theta over sine theta. We're multiplying that by sine theta. Oh, look, we can cancel. Sine theta divided by sine theta is 1. Cosine theta times 1 is just cosine theta. We simplified this original trig statement, trig expression, and found that it equals cosine of theta. All right, let's try another one. Secant theta times tangent squared theta plus secant theta. A couple things going on. We could replace tangent squared theta with what it equals from the Pythagorean identities, but we could also, it's added together, and this has a secant theta and this has a secant theta. I'm going to factor out a secant theta. So if I factor out a greatest common factor of secant theta, I get tangent squared theta plus 1. Now, what does tangent squared theta plus 1 equal? Look at your Pythagorean identities. You can go back in your notes, or you can look at your reference sheet, your pink sheet. What does tangent squared plus 1 equal? Tangent squared plus 1 equals secant squared. So we can replace that with secant. Not exactly secant. Tangent squared theta plus 1 equals secant squared theta. So replace it with secant squared. And then what's secant times secant squared? Well, what's x? Times x squared. X times x squared gives you x cubed, but we're doing the same thing but with secants. Secant times a secant times another secant is secant cubed. So now our exponent's a 3, and we have secant cubed theta. It's now simplified. And that's example 2. Funny thing about simplifying these, you can do these, a lot of them, more than one way and still get to the same answer. Example 3, verify a trig identity. Verifying trig identities. You can use the fundamental identities from this chapter to verify new trigonometric identities. When verifying an identity, begin with the expression on one side. Use algebra and trigonometric properties to manipulate the expression until it is identical to the other side. So the big thing to notice is that we are verifying that it's true. So we cannot do something to both sides of the equal sign. We are only going to manipulate one side. So this far right side is going to stay a sine squared theta. It is okay to work with either side, but as a general rule, you're going to try to simplify the side that looks more complicated, so that you're working it very similar to what we did example 2. We're going to take this and try to simplify it and hope and cross our fingers that it turns out to be sine squared theta. All right, secant squared theta minus 1. Let's go back and look at our identities. Find the one with tangent squared and secant squared. Okay, we want secant squared minus 1. So if we subtract 1 from both sides, we get tangent squared of theta equals secant squared minus 1. That'll help us see this secant squared minus 1? That is the same as tangent squared. Okay, we made a substitution using a Pythagorean identity. Now let's rewrite these using sines and cosines. The first thing I want to do is write this as two separate pieces. Tangent squared over 1 times 1 over secant squared. This helps me to break it up and see it as separate pieces. Tangent is the same as sine over cosine. So we have a sine squared over cosine squared. Times, what is the reciprocal of secant? Cosine. So 1 over secant would equal cosine over 1. And it's secant squared, so we would get cosine squared over 1. Now look at these two fractions together. Cosine squared divided by cosine squared is 1. So all that's left is sine squared divided by 1, and we get sine squared. We did it. Sine squared theta equals sine squared theta. It is a true identity. Woo! And that's example 3. Verifying an identity. You cannot work both sides. Notice I didn't touch anything on this side. Sine squared just stayed sine squared. I only worked one side of the equation. Notice that verifying an identity is not the same as solving an equation. When verifying an identity, you cannot assume that the two sides are equal because you are trying to verify they are equal. So you cannot use any properties of equality, such as adding the same quantity to each side of the equation. Okay, we want to verify this next identity. I'm only going to work one side. I'm going to leave this side alone and try to make this left side look like the right side. So secant x is the same as 1 over cosine plus tangent x. Tangent is sine divided by cosine. So one of the things to try is substitutions. Another thing to try is rewriting things using sines and cosines only. Notice we have two fractions that have a common denominator, so we can add those together. All right, here's where it's going to get pretty tricky. Looking at where we want it to be, what we want it to look like. We want a 1 minus sine x, and all we have is a 1 plus sine x, and it's in the denominator, and ours is in the numerator. So let's give it a 1 minus sine x. When you're not sure what to do, try something. This is a little unusual. Once you've seen it once or twice, and it might not seem so unusual once you see how it works out. So we're going to multiply the numerator and denominator. notice we're still just working one side of the equation. If we multiply these together, look, we have the difference, sum and difference pattern. When we multiply those together, we get 1 minus sine squared. Now that we've got a sine squared, that's helpful. Pythagorean identities all have something squared in them. Okay, and on the bottom, we now have cosine x times 1 minus sine x. Oh, what does 1 minus sine squared equal? Sine squared plus cosine squared equals 1. So 1 minus sine squared, if we move this over, cosine squared will equal 1 minus sine squared. So 1 minus sine squared is cosine squared. Over cosine x times 1 minus sine x. Look what happens next. What do you notice? This cosine x can cancel out one of these cosines so that we just have one cosine x on the top instead of squared. So it's just cosine x over, this is gone, 1 minus sine x. Look. Ta-da! We did it. Okay, that one was a little harder. We used that multiplying the numerator and denominator by the same thing so that it could have something that we wanted it to have to match the other side. But all we did was multiply by a form of the number 1 and then do more simplifying. Okay, that was example 4. That was a tricky one. All right, so let's kind of summarize a bunch of the different things I did. When we were simplifying or verifying trig identities, the most important thing is you try something. It may or may not work. Do a substitution, but try something. Rewrite using signs and cosines only. Like tangent is sine over cosine. Cotangent is cosine over sine. Things like that. Try to rewrite other functions using sines and cosines only. You can make substitutions. Use the Pythagorean identities or use a form of the Pythagorean identities. Notice we used these three quite a bit, but sometimes we solved for sine squared or cosine squared or tangent squared or cotangent squared. So there are other forms of these that you can still use. So if we wanted sine squared by itself, like we have a sine squared in our equation or identity we're working with, that could be substituted for 1 minus cosine squared. Because if we get rid of this, how do we undo addition? Subtraction. So this is also true. We could solve for cosine squared. And that would be 1 minus sine squared. And we can do that for tangent. If we solve for tangent squared, we would get secant squared minus 1. We could solve this one over here for cotangent squared. If we solve for cotangent squared, we would get cotangent squared equals, subtract 1 from both sides, cosecant squared minus 1. So there's all these different forms. We can solve for any one of those, and those are just another form of the Pythagorean identity, and we can make that substitution if it helps us. All right, so there's a list, but remember, try something and then see what happens. Exit ticket. Find the value of the other 5 trigonometric functions of theta when tangent theta equals 2. So tangent theta is 2, and theta is between pi and 3 pi over 2. Remember, all students take calculus. So these are the positive ones out of sine, cosine, and tangent. A means all. Sine, tangent, cotangent. We're pi to 3 pi over 2. So we're in this quadrant. Tangent is positive. That means sine is negative and cosine is negative when we find these. Okay. Tangent. Tangent theta is 2. And 1 plus tangent squared theta equals secant squared theta. Put your 2 in for tangent and solve. Two squared plus 1 square root of both sides, plus and minus. This is where we have to figure out our sign. So secant theta is a reciprocal of cosine, and we said it was negative. So this is a negative square root of 5. All right, we've got tangent, we've got secant. Let's find sine. Okay, it's all set up. Let's not do sine next. Let's do cosine next. Cosine is the reciprocal of secant, so that would be 1 over rad 5. And 1 over negative rad 5 would end up being negative rad 5 over 5. And then we can use sine squared plus cosine squared equals 1. Or we can use that tangent equals sine over cosine. Lots of different things we can do there. If we use that sine squared plus cosine squared equals 1, we would get, if we make this our x or our y, let's make it n. I'm picking a new variable, n squared plus negative rad 5 over 5 squared equals 1. We would get 5 over 25 subtract 5 25ths from 1, you get 20 25ths, and then we get n squared equals that square root. That'd be 2 rad 5 over 5. And that would be our sine. 2 rad 5 over 5. Which gives us then our cosecant. Flip it over, 5 over 2 rad 5, but multiply by rad 5 over rad 5. So we get 5 rad 5 over 10, which is rad 5 over 2. And the reciprocal of 2 is 1/2. Okay, that's finding all this using those Pythagorean identities. I want to show you one more thing with this. What if we didn't use the Pythagorean theorem identities? What if we just did it the way we did in a previous section? Tangent theta is 2. It's in this quadrant. Draw a reference triangle. Tangent is opposite over adjacent. Opposite over adjacent. So this side would be 2, this side would be 1, because 2 over 1 simplifies to 2. Use your Pythagorean theorem. A squared plus b squared equals c squared. 2 squared plus 1 squared is 5. Square root of that is rad 5. Now, using this triangle, sine, remember we always use our reference angle here at the origin. Sine is opposite over hypotenuse, 2 over rad 5. Simplify it, 2 rad 5 over 5. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse, 1 over rad 5. Simplify that, we get negative rad 5 over 5, because this is a negative, because we're in that quadrant. And sine is also negative. Tangent is 2. Cotangent is 1/2. Cosecant is a reciprocal of sine, and secant is a reciprocal of cosine. So you can use your reference triangle, or you can use the Pythagorean identities like I did over here. Personally, I like to draw these, but in this section, they really wanted us to use the new identities they gave us. Okay, big ideas assignment 9.7. It doesn't matter to me which way you get to your answers. I like my pictures better. All right, have a great day. Thanks for watching.